To understand how to do this question, firstly, okay, we have two functions. One is fx equals to lambda minus x minus plus 2 square. Okay, and then the domain is x greater than negative 2. So first you got to understand, this is a n-shaped quadratic. Okay, n-shaped quadratic where the maximum point is at negative 2. So you see, because this is lambda over here, lambda could be positive, lambda could be negative. So let's just assume that lambda is positive, it doesn't matter. Okay, and because they say x have to be greater than negative 2, right? It cannot be equal to negative 2, and it is a half a n shape going downwards, where the maximum point is negative 2 comma lambda. Okay, so from here you know that the range of fx is, the range of f is equals to from lambda to negative infinity here. Okay, cannot include lambda, so negative infinity to lambda and then close. Okay, so this is the range. For gx, it is a ln graph. So ln 1 minus x, x less than 1. If you put it into your GC, right, the GC is going to show you something like this without the asymptote. So you have to know that the asymptote of a ln graph, it depends on whatever is inside the bracket over here. Okay, so because the question didn't ask you to sketch, a small rough sketch will do. Okay, now the question says that the composite function exists. The composite function exists. So in order for the composite function to exist, the range of f, because I'm going to do gf, means that the x will go through f first, then it goes through g to become gf. So over here at the interchange, the range of f becomes the domain of g. Okay, so this is the part that you have to know. Okay, now my range of f is equals to minus infinity to lambda. My domain of g is from 1 to, sorry, less than 1. That means negative infinity to 1. Negative infinity to 1. So what is the biggest value of lambda such that it is a subset? Because in order for composite function to exist, range of f must be a subset of domain of g. So I know that lambda must be equals to 1, so that the range of f can be the maximum subset, means can be equal. Okay, exactly equal, equals to 1. And this is how we do the first part.